There are two questions that I am solving from oscillations. Both are simple questions. Each doesn't take more than a minute. That's why I have combined them together as a single question. Let me have a look at this question first. A particle executes linear simple harmonic motion with an amplitude of 3 centimeters. So let's write down the data given for us. Amplitude is given to us at 3 centimeters. When the particle is at 2 centimeters from the main position, that means to say his displacement is 2 centimeters. The magnitude of its velocity is equal to the acceleration. So let us try to see what he's saying. He's saying magnitude of velocity at that instant is magnitude of acceleration. We know for a particle in oscillatory motion, velocity is omega into root of a square minus y square, whereas acceleration equal to actually minus omega square y. When you calculate magnitude, we have to write omega square y because minus is a symbolic way of saying that displacement and amplitude are, for a displacement and acceleration are opposite to each other in oscillatory motion. So omega square y, that's what he has given. 1 omega and 1 omega can be cancelled. You want time period. So root of a square, substitute the value. 3 square minus y square is 2 square equal to omega into y is also equal to 2. Root of 9 minus 4 equal to omega can be written like 2 pi by t into 2, right? Then root 5 equal to 2 pi by t and 2. So t is equal to 4 pi. Pi of course is the root by root 5. That's an answer. That's how we get it, right? So if you got a doubt that how omega is 2 pi by t, it can be very easily explained as angular velocity can be written like rate of change of angular displacement. With the completion of one rotation, angle covered is 2 pi. Time taken for one rotation is called time period. Thus omega becomes 2 pi by t, and hence 4 pi by root 5 is the easy answer for that problem. That solved that question. That's second question. Let's have a much simpler first question. This was given in NEET 2019. The question says the radius of the circle, the period of revolution, initial position, and the sense of revolution is given in the diagram. Then what is the displacement is? So what we can notice is it has a time period of t seconds. It has a maximum possible displacement radius, that is amplitude. So amplitude is given for you as 3 meters. Time period is given for you as 4 seconds. As I have written in the other place, I can write omega as 2 pi by t, that is 2 pi by 4, that equal to pi by 2, omega equal to. Then for a particle in simple harmonic motion, wherever it is at a particular position, displacement can be expressed, which is equal to y, can be expressed as, we know the equation, y equal to a sin omega t or a cos omega t. Here sign format is not having a right answer, though we have one sign. Its amplitude is given as 4, which is wrong. Therefore, we have no choice other than taking cos format. So we assume that the vertical projection is drawn not onto the x axis, y axis. So displacement is measured along this direction, x or y, whatever you call it. So the equation is y with respect to time, displacement with respect to time is a, amplitude is 3, cos omega, omega we have already found as pi by 2, and t, where y is in meters, of course. So is the right answer is this one, 3 cos c, right? That's the right answer for the problem. That's how we get the answer. So both the problems are simple problems, and this understanding uses that sometimes they give even much simpler and easy problems in oscillatory motion too. That's it, and thank you for watching.